In the last two videos, we were looking at Kruski's section 9.2.2 that he referred to as a realistic model with MC, and I simply referred to as more realistic. But in reality, those two videos weren't really talking about something that was very realistic. So now what we're going to do is move on to something that is a little bit more realistic, which is Kruski's section, Therapeutic Touch. And in the previous videos, really what I was focused on was getting the code and thinking about the flow chart. And this is a more complicated example that's going to allow us to think about interpretation. So what is this therapeutic touch thing all about? Well, here we have an unhealthy patient, and here we have a truly gifted therapist. And what this truly gifted therapist does is they wave their hands over the sick patient, and it rearranges their energy field, and the therapist gets better. And so someone might be a little bit skeptical about that, but it does actually represent a testable hypothesis. So what we have here is our CHI, our funded scientist, and down here we have our therapist with their hands, and in between what we've got is a screen. So what our scientist does, our scientist takes their hand, moves it through a hole in the screen, and either hovers it over the left hand of the therapist or hovers it over the right hand of the therapist. And that is a choice that's made randomly. And then what the therapist does is the therapist responds by saying, okay, the scientist's hand was over my right hand, or the therapist says the scientist's hand was over my left hand. And we replicate this 10 times for each therapist, and we record the output as either success or failure, depending on whether or not the therapist was able to correctly identify which one of their hands over which the scientist's hand was hovering. So in terms of the data and flow chart, it's very similar to what we saw in the previous video with a few changes. So instead of having coin, we're going to have therapists. Instead of having just 3 coins, we're going to have 28 therapists. And instead of having ones and zeros defined as heads and tail, a 1 is if the therapist is able to correctly identify which one of their hands over which the scientist's hands was hovering, 0 if it was incorrect. And our flow chart is going to be essentially the same, except that instead of coin, in all these 3 cases, we're going to have therapist. And so if we look at our results, what we get are a series of thetas for each one of our 28 therapists. So these are our values of theta. What do they represent? If we come back here, there's theta for therapist. It's the parameter of the Bernoulli distribution from which the ones and zeros were randomly obtained. And these values, as we're going to see, may be of some interest. But what I'd like to say is that probably the most valuable number of all, is this one right here. And these 2 guys here are also quite important. And so I just want to take a few minutes to go over why I believe that. Some justification for that claim. So let's begin by thinking about a couple of different numbers. Let's think about omega with a median, with the the posterior distribution of omega has a median value of 0.436, and For the parameter kappa, its posterior has a value of 36.2. So what are these things? Those are the values omega and kappa of our prior distribution for theta. But there's another way we can think about this. So what I've done here is drawn a beta distribution with omega is equal to 0.436 and kappa is equal to 36.2. And this isn't necessarily a figure that the scientist is going to put in their publication, but it helps us, I think, give some clarity in terms of why this value of omega is going to be so important. And the way I look at this to say, okay, we've identified this thing here as our prior for theta. But there's another way we can think about this distribution. We can think about this distribution, this beta distribution, well, this is the beta distribution, as being the distribution from which the 28 different values of theta are randomly drawn. So from this distribution, we get theta 1, theta 2, theta 3, all the way out to theta 28, where these values, once again, are the Bernoulli binomial parameters from which the ones and zeros are obtained. But the point I would like to make is that if in fact these values of theta arise from some beta distribution, then what's really important? I would argue what's really important is this value of omega. Because this value of omega, what is it? It's the mode of the distribution It's the mode of the beta distribution that gives rise to, from which are selected, the individual thetas. And so we can view, therefore, omega as reflecting some sort of a general, overall ability of the therapist to detect the hand. So that's what's really going to be important. So now what we need to do is think about, okay, if it's omega, if it's the mode of this beta that's so critically important, now we can think about, okay, what's the posterior distribution of this critically important value of omega? And here we see it right here. Here's omega. There's our posterior distribution. And there's our median here of 0.436. And a 95% credible interval that goes to 0.509 here and 0.364 here. So if this omega, the mode of the beta distribution from which the individual thetas arrive, reflects the general ability of the therapists, it doesn't look to me like the therapists in general are doing terribly well. Because like this would be 50% chance of identifying the hand correctly, and not so good. So we've got here some pretty strong evidence that therapeutic touch is not a real thing. Now, this scientist may have had a second motivation in doing this experiment, because if therapeutic touch was a real thing, then what they might want to do is identify the best therapist and hire them, and then they could go around healing patients. So let's look at how the individual therapists perform. And our attention might initially be drawn to therapist 28. So there's therapist 28 right here. And we've got some open circles and some closed circles. And the closed circles are the percentage of times that the therapist was able to correctly identify the hand. And so therapist number 28 did really well and identified the correct hand 8 times out of 10. But the whole idea is this is a hierarchical model, so as a consequence of being a hierarchical model, shrinkage has occurred. So although the raw data suggested 80% as the score, once those values have been shrunken via JAGs, then the therapist didn't look so good. And we can go back up here and think about therapist 28. And we can go to our plots that are produced by JAG, and we can look at the posterior distribution. And what are we looking here at? This is our best guess, the posterior distribution of theta 28, where this would be the Bernoulli parameter from which the ones and zeros were obtained. So the raw value, therapist 28 managed to get 80% correct. But if we think about, as a consequence of this Bayesian analysis, what's our best estimate of this idea, the posterior distribution of their Bernoulli parameter? Well, it's a lot less than that. And so by incorporating shrinkage, what we're essentially seeing is that this therapeutic touch isn't a real thing. And once that shrinkage has been applied, our estimation of the talent of therapist 28 goes down by a very large amount.